Hi everyone, in this video I'll take a closer look at this project. I'll show you how I created glass and water materials, how to create thunderstorms in a few minutes and how to set up lighting in the project. I'll show you how to animate scene components and materials. In the end we will analyze the project settings for the final rendering. Don't forget to hit like button and subscribe to my channel for more exciting content like this. Your support means a lot. Before we start, I want to recommend you my course to help you learn how to create interactive visualization for your projects. Interactive visualization in Unreal Engine is a new level in the presentation of your projects. Gain a competitive edge and impress your clients. Link in the description. Although visualization with the Lumen method is now especially popular because it gives a very fast and high-quality result. In this project I used the Path Tracer method. It was important for me to get high-quality, physically accurate photorealistic renders. Path Tracer is the most accurate rendering method available in Unreal Engine. I made a 3D model of the building in 3ds Max and exported it to Unreal Engine using Datasmith without materials. I customize all materials for each project in Unreal Engine. For the environment I used assets from the Megascans library. Basically all the assets from the Sandstone collection. To light the scene I used BP Light Studio from the starter content and an HDRI map. This is a great tool if you need to quick set up the light in your project. To add BP Light Studio to your project, you first need to load starter content into the scene. In the content browser, click Add, Add Feature or Content Pack, Content, Starter Content. In addition to BP Light Studio, starter content contains many useful resources, such as materials, textures, fire and smoke effects. BP Light Studio is located in the Starter Content Blueprints folder. Drag it into the scene. Activate Use HDRI. To remove this warning, you need to change the mobility of the Skybox component. Select BP Light Studio in the Outliner panel, Skybox. Change mobility from static to stationary. In the same way, adjust previous arrow. The warning is gone. The Night Sky HDRI map I took from polyhaven.com. It's a great resource with free assets and textures. Choose HDRI map resolution based on the performance of your system. I usually use 8K. Let's move on to setting up BP Light Studio. Place the HDRI map into the HDRI Cube map slot. Don't forget to adjust the exposure in the post-process volume so that the light of the scene is displayed correctly. In my case, manual mode. Exposure compensation 9. To adjust lighting, switch view mode to Path Tracing. Now you can adjust the brightness and contrast of the HDRI map. By adjusting these parameters, you can control the illumination of the scene. In this project I don't need the atmosphere effect, so I turned it off. You can see how the atmosphere affects the overall lighting. For artificial lighting, I used rectangular light sources. If you do not want the light source to be reflected in mirror surfaces, you need to set the specular scale parameter to 0 in the light source settings. But in my case, reflection do not spoil the picture. Notice how the light takes on the color of the glass. Lumen, unfortunately, cannot provide such an effect, as well as physically correct caustics. In order to enhance the effect of depth of space, I added exponential high fog. Exponential high fog only works with Path Tracer in volumetric fog mode. To make fog appear, you need to activate volumetric fog. To achieve the result I wanted, I also adjusted some parameters, such as fog density, scattering distribution and albedo to give the fog a blue tint. Let's move on the materials. For all surfaces of the project except glass and water in the pool, I used materials from the Megascans library. For glazing I created my own material. Let's look at its structure. Base color, metallic and specular I converted to parameter. In this case, base color performs an auxiliary functions and affects the strength of glass transparency and the hue of reflections. The absorption medium chain is responsible for the main color of the glass. Absorption color set the base color. Let's see how it works. Material instance of yellow glass. Now I'll try to change the base color. If I change from black to white, it only affects the transparency. But if I try add a color, an additional color appears in reflections that can be seen from different viewing angles. In this case, the reflections take a blue tint. By experimenting with absorption colors and base color, you can achieve interesting results. Let's consider other material parameters. To add the effect of dust and scratches to the glass, I used a deer texture that I connected into the roughness slot. To control the intensity, I use the multiply node. For opacity, I use the Fresnel node. It allows to create an uneven transparency effect. The object is more transparent in the center and less transparent at the edges. The Fresnel node serves as a mask between the parameter 0 and 1, where 0 is transparent and 1 is not transparent. Next, normal. If you look at an example of real facade glazing, you can see that the glass has distortion and deformation. To simulate this effect, I added a normal map. For refraction, I also used Fresnel to blend two refractive indices. I took indices from the list of refractive indices for different materials. Now let's move on to the pool water material. The water material is similar to glass but has important differences. To simulate the effect of caustics, I used a water texture that I placed into absorption medium. I added nodes to control the contrast and color saturation of the caustics. Two water texture samples are the same texture but they have different animation speed and direction to make the caustics varied. Panner nodes are responsible for the animation. X and Y set the direction of movement of the texture. The larger the value, the higher the speed of movement of the texture in a given vector. These textures are then blended using a Perlin noise mask, which also has motion. At the end of the chain are nodes responsible for the size and position of the caustic textures. Opacity and reflection have the same structure as the glass material. Now consider normal. There is mixing of two different normal maps, which are blended using the blend angle corrected normals node. Each texture has its own animation, then the node responsible for the size of the texture. These nodes for the strength of normal. Material instance settings. Let's take another look at the end result. I like how the water looks. Write in the comments what you think. Let's move on to creating a thunderstorm. To create the lightning effect, I used a real image. Then I prepared a black and white image that will work as a mask. I also created a gradient texture, which I used to create the effect of the gradient appearance of the lightning from the sky to the ground. Let's see the structure of the lightning material. This is a simple material, nodes for lightning color and brightness. The texture of the lightning mask that forms its shape. Linear interpolation creates the effect of lightning appearing and disappearing. With the help of gradient texture, lightning appeared from top to bottom, from the sky to ground. This parameter is responsible for this process. Let's see how it works. I'll create a new plane and apply lightning material instance. By changing the value of the gradient parameter, you can see how the lightning appears and disappears. Then all that remains is to place the plane in the right place of the scene and animate the material in the level sequence. Let's move on to animation. I have created several cameras. For each camera separately, I created a level sequence. Let's see the level sequence for camera 0. As you can see, as the camera moves, the zoom changes at the same time. This technique allows you to achieve an interesting effect that is similar to time-lapse shooting. To achieve this effect while moving the camera away, you need to increase zoom. I animated the current focal length. On frame 0, I set the value to 12 and for the last frame to 40. To adjust the position of the sky for each camera and also to enhance the effect of the movement of the sky, I added BP Light Studio to the sequence. Next, I need to access the animation of the parameter responsible for the rotation of the texture. First, I need to add the skybox component. Next, I need to access the material parameters. To do this, I added element 0, which is the material of the skybox component. Next, I need to add a texture rotation parameter. Cube map rotation. Now I can animate or position the sky for this sequence by creating animation keys. Let's create the thunderstorm animation. First, I need to add a plane to the sequence to which the lightning material is applied. In my case, it is plane. Then add a static mesh component. Next, material element 0. Now the material parameter, in my case, is gradient. It remains only to create animation keys in right place. Delete the first automatically generated key. First key 65 frame. Value 20, which makes lighting invisible. Next frame 72, in which the lighting in its brightness state, value 0. And one more key on frame 92 for the smooth disappearance of the lightning. I hope you understand the principle of work, and now we can move on to the rendering settings. Path Tracer, unlike Lumen, is easier to set up. Go to Post-Process Volume and find the Path Tracing tab. I left max bounces and sample per pixel by default. Filter width I set to 1. Decreasing this value makes the image sharper. I set max path exposure to 8. This is an important parameter that affects the artifacts that are visible in the animation. For example, let's compare two draft animation fragments. On the left, max path exposure is 30 by default. On the right, the value is 4. Strong artifacts are visible on the left. On the right, the animation looks much better and cleaner. As you can see, a lower value gives a better result. I recommended choosing a value individually for each project. Next, I activated all the components except for the atmosphere, since I didn't use it in this project. Let's move on to setting up the render movie queue. Image format EXR. This format has a wide dynamic range. Path Tracer, all default settings. Anti-aliasing, spatial sample 500, temporal sample 1, override anti-aliasing. Game overrides with default settings. Output 4K resolution. Now the final part of the project. When working with a sequence of EXR images in video editor, you may encounter the problem that the picture is too dark. To solve this problem, you need to change the gamma. For video editing, I use DaVinci Resolve, and I will fix this with the built-in LUT. Select a video fragment and proceed to editing it. Add a new correction node. LUT VFX.io Linear to Gamma 2.2. Now the video clip looks correct. I hope this video was helpful to you. Link to the source file for this and my other projects in the description. Don't forget to hit the like button and subscribe. Thanks for watching.